this lecture. Okay, so let's discuss this quiz now. So in this first case, we're asked to classify substances as, so let me switch to the drawing tool, as homogeneous mixtures, heterogeneous mixtures, or pure substances. So in our first example, we're dealing with HCl aqueous. So what does the aqueous symbol imply? Yep, dissolved in water. So this is dissolved in water. So if we have a substance dissolved in another substance, we have a solution. What is that? Is that a homogeneous mixture, heterogeneous mixture, or pure substance? Do we have two or more pure substances mixed together? Yes. And is it homogeneous or heterogeneous? Homogeneous. Yep. So we'd classify this as HM. Okay. The next example is syngas, which is commonly used in the production of chemical building blocks. It's a colorless gas containing carbon monoxide and carbon dioxide, among other components. So if it's a clear, colorless gas, is it going to be a mixture or a pure substance? Homogeneous mixture. And the reason why it's a mixture, we see two different chemical formulas indicating two different pure substances. So this is a homogeneous mixture. Okay, in the next example, you're going to be asked to classify the following as either a physical or chemical change. So for example, if a solution of alcohol is boiled, so keyword boiled, phase changes, are they physical or chemical changes? Physical, yep. There is no change in the chemical formula during a physical change. Phase changes don't change the chemical identity, they only change the physical state. Okay, solid copper is added to a clear liquid, then the solution turns dark blue. So we notice an indicative color change. What are color changes a signal for? Physical or chemical? Chemical, exactly. Okay. Continuing on, we're now asked to classify the following, in this case, pure substances, as either an atomic element, a molecular element, or a compound. So starting off with nitrogen, N2 gas. So first and foremost, do we see two or more different element symbols? No, we just see one, right? So it's an element. Now the next question is, do we see two or more atoms? Is it atomic or molecular? Molecular. Yep, we see N2, so we have two nitrogen atoms, and if we have two or more atoms, that is a molecular element. So we'd classify this as a molecular element. Okay, let's now move on and discuss NO3. So this one's pretty straightforward. Do we see two or more different elements? Yes, ergo it is what? Compound. Okay, perfect. Okay. Looking at copper solid, is it an element or a compound? Element. And does it have two or more atoms or just one atom? Just one. So we'd call this an atomic element. The reason why we're going over this in detail is because you want to be able to very quickly, towards the end of the next chapter, write out the formulas for each of the corresponding elements and quickly identify whether they're atomic or molecular. Because when we say copper, you're going to need to know that corresponds to an atomic species. That's the goal of this process. Okay, let's now perform the following calculations to the correct number of significant figures. So first and foremost, let's take a look at this top operation. So we're doing a division operation. So what do we care about? Division, we care about what? Sig Figs. So this top number has how many Sig Figs? 4. Yep, we have 4 Sig Figs to work with. Okay, now this bottom number of 1.50 has how many significant figures? 3. Yep. Okay, perfect. So we have 3 Sig Figs. So how many significant figures should we report in our final answer? In multiplication and division, we report the least number of Sig Figs, which is 3. So let's break out our calculator. And let's punch that in. So we have 6.525 divided by 1.50. And that gives us, conveniently enough, 4.35. Okay, so let's enter that number. So 4.35 does that number have 3 sig figs? 4.35. Does it have 3 sig figs? Yes. Perfect. So are we good to go? Have we followed the sig fig rules? Yes. Okay, in this next operation, we're dealing with subtraction. So let's write out our numbers here. And the reason why I like to set them up just like we did in, for example, grade school addition and subtraction is because for addition and subtraction operations, what do we care about? Sig figs or decimal places? And if you set it up where the decimal points are aligned, it's very easy to count the decimal places. So looking at this top number, it has how many decimal places? 2. Has 2 decimal places. This bottom number has how many decimal places? 2. Okay, so we punch this into our calculator really quickly. 10.34 minus 1.45, and that gives us 8.89. Okay, so let's enter that in, 8.89. Looking at our output number, does our output number have 2 decimal places? So have we retained the least number of decimal places? Yes. Okay, this last example requires a little bit careful rounding. So if we have 25.0 times 1.05, what do we care about if we're multiplying 2 numbers together? Sig figs. And both of these numbers have how many significant figures associated with them? 3. Both of them have 3 significant figures. So our final answer should have how many sig figs? 3. So let's punch that into our calculator. So we have 25.0 times 1.05. And that in turn gives us 26.25. So let's write that down. So we have 26.25. Now, if we want to round this number, if we want to round this number to 3 sig figs, where is the 3rd significant digit in this number? The 2. Okay, so let's switch colors for that. Okay, so let's underline the 2 and let's look 1 space to the right. So we've underlined our 2, we look 1 space to the right. Is 5 greater than or equal to 5? Yes. Yes. Ergo, do we round up or down? Up. So that gives us 26.3. Any questions on any of these examples? Okay, the solution will be posted on Canvas shortly, and it's also as part of this lecture recording. So continuing on, let's finish up chapter 1. And there are a few additional addition examples that we did, but we're going to focus next on combining addition, subtraction, and multiplication and division into more complex calculations. So give me 1 moment to set up the proper Zoom for this. Okay, perfect. Give it 1 moment to stabilize. And now let's talk about actual calculations that you'll be doing. We're often not just doing a simple addition, subtraction, multiplication, and division operation. We often have to do multi-step calculations, right? You're going to add 2 numbers together, then multiply them, etc. So for significant figures and multi-step calculations, what you're going to do is you perform the given mathematical operation based on order of operations. I believe the common acronym is PEMDAS. Essentially, you're going to deal with parentheses, then exponents, multiplication, division, then addition and subtraction. So we're following order of operations, and all you have to do is follow the significant figure rules for each step. Treat each step individually. Now, the key feature for multi-step calculations is do not round off before the end of the calculation. So we're going to have to develop a method of keeping track of our significant digits because you should not round before you're done. That can introduce rounding error and your answer can be dramatically off. So non-significant digits are carried through and are noted with a lowercase notation or bar notation to signify the last significant digit. So for example, in 457, if this 7 is lowercase, all the lowercase numbers, all the subscript numbers are considered not significant. So how many significant figures am I trying to convey here? How many non-subscript numbers do I have? 2. So how many sig figs am I trying to convey to you with this number? 2, exactly. So this number functionally has 2 sig figs because this subscript 7 is not significant. A far more convenient method for handling long numbers is bar notation. So in this case, we're taking 457. What you do in bar notation is you place a bar above the last significant digit. So for example, in this example, I put a bar above a 5. Ergo, what's our last significant digit in this number? 5. So how many sig figs does this 457 have with bar notation? 2. Okay, wonderful. So this has 2 sig figs. This is really important because we want to make sure we're following the sig fig rules for each step, and we need to know what digits are significant and what digits are we carrying through to ensure our calculations are accurate. Okay, so what I'm going to do is I'm going to showcase a relatively difficult example, and I'll show how we utilize bar notation to get us from start to end. So let's treat this complicated operation one step at a time. So first and foremost, we have a set of parentheses. So we're going to deal with the operations in the parentheses first. So let's start with this addition operation. So we have 4.04 plus 143 dot. Okay, perfect. So since we're adding numbers together, what do we care about? I hear decimal places. Yes, that's correct. So this top number has how many decimal places? 2. This bottom number has how many decimal places? Are there any numbers after the decimal point? 0. Okay, so our next step is we're going to add these numbers together. And I don't think we need a calculator for this. This is 147, okay, 0.04. Now, in our final answer, how many decimal places should I report? What's the least? 0. Okay, so we want to convey this number as having 0 decimal places. So what we're going to do is we're going to break out our bar notation, and we're going to indicate the last significant digit. So where is the last significant digit in our final answer? Where do we need to place our last significant digit? The 7. Because should we have any numbers after the decimal point? No. So we put a bar over 7. There we go. Perfect. So our first component is done. Now, just from counting purposes, how many effective significant figures does this number have? 3, because we have the 1, the 4, and then we stop at the 7. Does that make sense? Okay. So this has 3 sig figs. Just for note later on. Okay, in our second operation, we have 3.550 plus 5.4090. Okay, and just like before, since we're adding numbers, what do we care about? Decimal places. This top number has how many decimal places? 3. This bottom number has how many decimal places? 4. Yep. So how many decimal places should our final answer convey? 3. Okay. With that established, let's now switch and let's punch this into our calculator. So we have 3.550, okay, plus 5.409. Okay, and when we push the equal sign, we end up with 8.959. So let's enter that. So we have 8.959. Does this final output number have 3 decimal places? Yes. Do we need to break out the bar notation? No. This number, as is, conveys the exact amount of sig figs this number has. Okay, now we have these 2 numbers, and our instructions tell us to multiply these 2 numbers. So let's do just that. Oh, One moment. Okay, so let's do just that. Let's multiply these two numbers together. So we have 147.04 with a bar over the 7 times 8.959. So since we are multiplying numbers, what do we care about when we're multiplying numbers? Sig figs. And as we established, this 147 has how many sig figs? 3. So we have 3 sig figs, and 8.959, as we've established, has how many sig figs? Not decimal places, sig figs. 4. Okay, so how many sig figs should we report in our answer? 3, yeah. Okay, so with that established, let's now break out our calculator. So we already have 8.959 sitting in our calculator. So all we need to do is hit the times sign and we enter 147.04. Do not neglect to include even the non-significant digits in your calculation. This minimizes rounding errors. If you truncate your numbers early, you could end up with a number that's substantially different at the end of your calculation. This is especially important if you're asked to enter a number in Canvas or asked to select a number from a multiple choice prompt. So let's hit the equal sign and we get the following very large number. So we get 1,317.3. Okay, so we have that entered into and completed from our calculation. Now, if we need to round this number to 3 sig figs, what digit is the third significant digit? The 1. Yep. Okay, so now all we have to do is look to the right. And my question to all of you is 7 greater than or less than 5? Greater. So do we round up or down? Up. Now, it's really important, since this is a large number, you need to account for the magnitude, so you need to have placeholder zeros. So this gives us 1,320. Make sure you do not forget to include the placeholder 0. This isn't 100, it's 1,000. And the placeholder 0 is essentially saying this is a large number, but this 0 is not significant. Does that make sense? You could also use scientific notation. That's also perfectly valid. And let's show how we would do that. So that would be 1.32 times 10 to the third. Both methods are acceptable. Why did I not write this as 1.320? Is it okay for me to include a 0 in scientific notation? No. And why is it not okay? It's not significant, exactly. If we put a 0 at the end of this number, it would have 4 sig figs instead of the desired 3. Does that make sense to everyone? Okay, so let's have you do some practice now. Let's have you do some practice now. And I'd like you to attempt the following 3 calculations and make sure to follow sig fig rules and rounding rules for each step. Do not round until the end. Some of these examples are designed to catch cases where students round before they're at the end of the problem. Okay, and I'll be walking around to check to see how everyone's doing on this. Oops. Oh, we're growing. Yep, any questions? Any questions? So looking at this number, how many sig figs? So your answer is correct following the rules. But just to be clear, in this first operation, how many sig figs should your answer have? Okay. So you did retain. So you wrote out the full number, but there was no in this top portion. This 1 is the only significant digit.
Oh.
So then when you add those numbers together, are you able to round to 2 sig figs? So the calculation is correct. It's more just the final rounding.
Yeah.
You should be looking from the 1 to the right instead of the 6.
Oh. Thank you.
So let's talk about this next example. So looking at this problem, we have a multiplication operation followed by an addition operation. So let's compute this out. So first things first, we're going to handle things in order of operation, and the first operation that we have to do is multiplication. So we have 5.4 times 2. Okay, now since we're dealing with multiplication, my question to all of you is, what do we care about? Decimal places or significant figures? Yep. And the top number has how many significant figures? 2. And the bottom number has how many significant figures? 1. Okay, so then our final answer should have how many significant figures? 1. So if we multiply this out, we get 10.8. And from this 10.8, we are to retain 1 sig fig. So if we break out our bar notation, where do we put the bar? Over the 1. Now this is critically important for our second operation. Since what we're going to do is we're going to take 10.8 and we're going to add 6 to it. So when we follow addition and subtraction rules, we are concerned about decimal places or significant places in our number. And if we compare 10.8 and 6, what is the largest place that has a significant digit? So if we compare, we're looking at 10.8. Is this 0 in the ones place significant? Is this 0 significant? No. We only established this 1 is the only significant digit. So we can only report up to the tens place. So when we compute this calculation out and we get 16.8, what place are we rounding to? So we've established the tens place has the only significant digit in 10.8, right? So what place are we going to round to? The tens place, exactly. So following that logic, we're going to look 1 space to the right. We see a 6. So do we round up or down? Up. So that would give us a grand total of 20. Does that make sense to everyone? Key things to keep in mind, you treat and follow the significant rules for each step separately. Okay, let's continue on with this next example. We have 500 times 3.0 plus 4.5. Okay, now looking at the following example, in the first operation, we are multiplying. Now comparing these two numbers, just at a first glance, how many significant figures should our first answer have in this first multiplication operation? 1. So we'd get out 1,500, but we're only allowed to report 1 significant figure. So what is our significant digit in this number? In the thousands place, or the 1. Now, if we try to add this pitifully small number of 4.5, okay, we can certainly add them together, and we get 1,504.5. But where is our significant decimal place? Where is our significant place? In the thousands or the ones place? What can we report up to? What's the largest place that has our last significant digit? The thousands, right? So then we are only able to round to the nearest thousand. So if we look to the right, looking at our number to the right of 1, is 5 greater than or equal to 5? It's equal to, so do we round up or down? Up. And that in turn gives us 2,000. Okay, let's continue on with these examples. So suppose we have 1.5 minus 0.6. So in this case, we are doing a subtraction operation. So what do we care about? Decimal places. So how many decimal places do each of these two numbers have? 1. So how many decimal places should we report in our final answer? 1. Okay, so taking 1.5 minus 0.6, that in turn gives us 0.9. Okay, now we multiply our number. 0.9 times 2.0. Oh,